What's happening, folks? Geologist Philip Prince. I'm going to do a French Broad River video today. I'm going to talk about the Swannanoa River as well. A lot of folks have asked for this video. You've been following the Helene story. If you lived through it, you've undoubtedly heard about Asheville, Swannanoa, and what happened in these locations. I'm going to use these digital elevation models, like we've used in some of the other river videos, to try to give you a sense of how this landscape is laid out, where the French Broad River actually comes from, and how it sort of changes as a river moving from its headwaters in some of the highest mountains in western North Carolina down through Asheville and past Marshall and beyond out into Tennessee. Using these elevation models is a useful thing to do because it gives you a chance to see where the high points and the low points are in the landscape. You can actually see the river valley sort of snaking across the landscape there. And this is a way to really connect with the landscape and look at the natural controls over how it behaves, right? When you're living on the landscape, working on the landscape, sometimes you sort of forget or you don't get a chance to see what's actually there in terms of the natural structures. But that's what's going to be controlling where the water's going, how that water's moving, and that is what's going to interact with human constructions to cause a lot of problems with a flood event like this. Now, I'm going to zoom out real fast here and try to give you a sense of just where we are in in North America, in the United States. Going to leave the overlays on there. You can actually see the French Broad River Valley at the big scale from here. There's kind of a yellow streak running almost north-south across those overlays, and that is what's called the Asheville Basin. It's the big broad valley that the French Broad is actually flowing through. Why was there so much rain and flooding with this event? Essentially, what we're illustrating here. Moist air was drawn from the Gulf of Mexico for days prior to Helene. Helene also came from the Gulf of Mexico, brought a tremendous amount of moist air with it. And there's no high topography between the Gulf of Mexico and western North Carolina, particularly the Blue Ridge Escarpment, which is sort of the first topography that air is going to hit as it moves from south to north from the Gulf of Mexico into the Appalachians. And because that topography there is the first stop, it's going to force that air to rise, expand, and cool. And that's going to force really catastrophic rainfall, essentially in the same places, just for a really prolonged period of time. That's the source for all of the rain and the water that fell in the landscape. And then all of that water began to drain into streams and rivers. And at this point, it will be good to actually trace out where the French Broad River flows, where it starts, where a lot of its big tributaries come from. And I think when you see that, you'll get an impression that, first of all, it's a very interesting river system to look at in a better context because it interacts with the mountain landscape in a pretty unique kind of way. But in terms of the Helene event, it was sort of tailor-made, much like the Nolichucky and its headwaters, to sort of scoop up as much catastrophic rainfall as possible and send it downstream. So where does the French Broad begin? It's sort of tough to choose that, but I'm going to start it up here at the West Fork, up above Rosman, North Carolina, actually be right kind of up there on the Blue Ridge Parkway, making our way downstream here, actually passing Asheville there, passing Marshall, passing Hot Springs, all the way out here into Tennessee and actually into Douglas Lake. Okay. Let's add some tributaries. This is going to be the middle fork of the French Broad. This is the East Fork, the French Broad. We'll do the Davidson River coming down here. We're going to do, let's see, we'll do one of the Mills Rivers. So we'll do the South Mills River right here. We'll do Cane Creek. It's not a huge tributary, but one that was absolutely catastrophically flooded during Helene. Have the Swannanoa River coming down, meeting the French Broad right above Asheville. We'll do another Swannanoa tributary. Going to do Hominy Creek coming down from near Canton as well. Okay, so what I've drawn on there so far are areas that were feeding water to Asheville. I'll add one more here. I think this starts off as Bat Fork above Hendersonville. We'll add that one in to kind of round things out there. So that's kind of the French Broad layout there. And we'll hop out of here and actually fade the overlays away. It's sort of an interesting layout to a river channel. It looks almost like a like an upside down T, I guess, and a lot of that stream length sort of runs roughly parallel to the edge of the Blue Ridge. Now, if you were to draft on here where the highest rainfall was with this storm, it's going to be something something kind of like that right there with some real high points on these higher mountain areas. And if you match that up, we'll probably put another one here right at the escarpment as well. I know Honesty down there had like 15 inches before Helene ever arrived. If you look at where those areas are and how they match up with, with the French Broad, it's going to be collecting a vast amount of runoff and funneling it all downstream. We'll mark Asheville right there. We'll have Marshall right there for reference, right? So in this particular case, just the layout of the river system and how that interacted with the rainfall put a huge amount of water into the French Broad just because of where it starts and how it sort of lines up with the front of the mountains there. Now, what does the French Broad itself actually look like? Its channel changes quite a bit moving downstream. If we look sort of in the vicinity of Mills River, general area we're looking at here, right in the middle of the screen, you can see that there's a big area here where you don't see a lot of this ruggedness. You don't see that shading that's associated with rough topography and a lot of elevation difference. In this particular area, there's a huge amount of flat land very close to the river and very close to the river's elevation. Now, I don't use the word floodplain here because that actually carries like a legal definition. But I will say that there is, the huge amount of this flat land that's at low elevation compared to the river. And if we fade the overlays away, see there's a lot of agricultural land there. You can see the Asheville airport just north of it here, right? So this agricultural land is occupying areas that are close to the river, and it's very easy for the river to spread way out if its level raises far enough for it to do that, right? So keeping that pattern in mind, how's the river going to change if we make our way downstream, which in this case is to the north? We're heading towards Asheville here. And very quickly, you stop to see those big expanses of flat area close to river elevation. What we see is kind of the river here, which is the river and a little bit of flat area close to it. It's much more narrow and more confined, and the land rises up very quickly right next to it. Right now, the center of the screen, you got the Swannanoa River coming in to meet the French Broad. That's going to be, again, just upstream of Asheville. We'll zoom in a little bit closer here and actually focus in on what's going to be sort of like the River Arts area here. I need to switch those overlays real quickly. Okay, so let's fade this away, get a sense of what we're looking at here. So there's the 240 bridge right near the center of the Google Earth imagery there. River Arts District on the east bank of the river. And within this area, like I said, the river's layout with respect to the landscape is just different from what it is upstream. There's significantly elevated areas right next to the river. If you're down on the river in River Arts and you look up to one side, you're going to see elevated topography. If you look across the river, you're going to see that as well. There is a little bit of low elevation flat land next to the river channel, but it is much more confined than it is upstream. Now, the difference here is that the river is much bigger. It carries much more water, much more areas draining to it. So when all of that flood water, all of that rain that entered the streams and then the river as runoff gets to this area, it's much more walled in. It can't spread in the way that it can upstream. And having that walled in geometry with this really big volume of water is going to make a very rapid kind of high velocity flow that's going to sort of entirely fill that that confined area there. So it's literally a different setup of river valley from what you would see upstream around Mills River. Downtown Asheville is sort of up on top of a hill. It's actually up here well above the river, so it's out of harm's way in this case. But there's a lot of building right along the river, utilizing those little corridors of flat buildable land. But in a landscape like this, with the confinement on a river of this size, if you have an event like this, that's gonna present a problem. If we keep making our way downstream here, it becomes easier and easier to sort of follow the river here because it is entrenched further and further into the landscape. If you watch the Nolichucky video talking about the cane and the toe, their landscape looks quite a bit like this as well, where the larger rivers are very much cut into the landscape, and up above that you have sort of this rugged kind of upland area. Right now, we're looking down at Marshall. Marshall's right around the center of the screen. Again, you can see the river clearly here, and we'll fade that overlay away, and we'll actually see the town of Marshall, which kind of hugs the bank of the river, again, making use of what little bit of isolated, kind of flat, buildable land there is within what's an otherwise very rugged landscape. In many parts of the river here, there literally is no flat land next to the channel because it's cut down into the landscape. You'll see me make this gesture a lot during this video, and that's just me trying to illustrate that the shape of the river valley, how it sits in the land, you have to drive way down to get to Marshall. If you're back here on the highway and you actually want to get to Marshall itself, you're going to get on curvy roads and drop quite a long way. And that is a product of the river being very much cut into the landscape. And at this point, it's a huge river. It's collected so much drainage since it began up there near the Blue Ridge Escarpment with much higher elevations. It's got a massive volume, but it's a much more confined channel. It doesn't have to rain here very hard for Marshall to have a devastating flood because the river is bringing that flood water to it, and there's not a way for it to spread out there. So again, you're going to have a high velocity flood basically through the entirety of that valley area, that river corridor, and you're not going to inundate buildings. You're going to inundate them and probably wash several of them away because the river is going to be moving that quickly. If you zoom out here, this is an interesting pattern to consider within the overall Appalachian landscape. The French Broad's a really big river here. It starts off at very high elevation, then it sort of flattens out. And as it gets bigger and bigger, it actually begins to steepen again before it flows out here into the Appalachian Valley and Ridge. So the question is, why is the river laid out this way? Why does the river tighten up and get steeper as it gets bigger and bigger? Usually in geology, you would expect sort of the opposite of that. As the river gets bigger, it's going to flatten and kind of slow down. It has a lot to do with just the overall structure of the Appalachian Mountains and why this landscape looks like it does. So I'm going to try to sketch that out here real quick. It's going to be a drawing that's sort of similar to some of the older content on this channel, which is more related to structural geology. But I think it will give you a sense of where the French Broad flows and how it interacts with this landscape and how that in turn controls what the river actually looks like. When we come back, I'm going to focus up here on the Swannanoa River, which reflects some of these characteristics and has sort of an interesting interaction with the French Broad that also contributed to the devastating outcomes there. So hang on just a minute. Okay, so the layout of the French Broad is very much a product of Appalachian Mountain structure. And if you have seen some of the older content on this channel, you know that structural geology and sort of the layout of rocks under the earth at the very large scale is something I spend a lot of time working with. We're going to try to simplify some of that here to give you a sense of why the Blue Ridge landscape looks like it does and how that is an expression of what's down underneath it. And first thing we'll lay out here is a representation of valley and ridge, aptly named, of course, because it's dominated by really long straight ridges and the accompanying really long straight valleys. This is an area that has developed on top of folded and faulted, really sort of like stacked or shingled is a good way to describe the rocks there. They're sedimentary rocks, and certain sedimentary rocks, particularly sandstone, are very resistant to erosion, and those make mountain ridges. Sedimentary rocks like limestone and shale are very easily eroded, and those make valleys. So when you see the valley ridge, it's extremely conspicuous in the Appalachian landscape, and it's very much a direct product of what's under there, which you're going to see momentarily. Now, as you make your way east, the outermost part of the Appalachian Blue Ridge, something that you might see around Hot Springs or even further south down around like Gatlinburg or something like that. It has some characteristics that are similar to the Valley and Ridge in the sense that you do see elongated, straight, sort of geometric ridges in a way that you don't even further east in places like Marshall. And by the time you've gotten to Marshall and places further upstream, of course, like Asheville within the Appalachian Blue Ridge, you're looking at a very, very different sort of grain, if you will, to the landscape. And that grain is an expression of the fact that there is very different bedrock geology underneath the Earth's surface there, and that bedrock geology is controlling how the landscape is shaped. And then when rivers flow across that bedrock and cut into it, as a result, they're going to have sort of their own distinct characteristics. Likewise, when the rivers have to switch between these different rock types, you can expect to see some changes there, and that's sort of the moral of the story when it comes to understanding why the French Broad is set up in the way that it is. And we'll keep adding a little bit more of the high topography here, and momentarily we're going to have to add ourselves in a Blue Ridge escarpment here to sort of define the edge of the Blue Ridge. So here's our escarpment coming across, and I'm going to have a gorge or two cutting into the escarpment there. All right, so that'll work pretty well. We'll add one more little gorge, something almost like you might see around Chimney Rock, where you have that very distinct sort of cross-shaped gorge there sticking into the Blue Ridge. Okay, so there's your topography. There's different zones in it. We might add ourselves one more little rugged area right here just to kind of fill in that big open valley. So why does it look like this? If you were to cut it open, see sort of an interesting pattern. Basically, the rocks of the Blue Ridge have been pushed up and over the sedimentary rocks of the Appalachian Valley and Ridge, and those have been pushed up and over even more sedimentary rocks out into the Appalachian Plateau. So the structure of the overall Appalachian Range is one of big masses of rock that have been sort of shingled or again kind of like stacked on top of one another. And that occurred a long time ago. They're very deeply eroded now, and with that erosion, the geologic differences have been very much kind of etched out in the landscape, right? So I'm actually going to color this one in a little bit here. Let's do that. Might need another color to show that we've got a Piedmont over here. Do something like this. It's always fun to use the color filling tool here and paint. All right. This is pretty good. Need one more color here. I'm try to adjust that one a little bit. Something like that. Very good. Okay, so now we've got some geologic structure down there under the surface. And if we label different areas here, we got the Blue Ridge, got the Piedmont out here at the far right. And we got the Valley and Ridge here to the west of the Blue Ridge. Let's put a river on there, kind of like a French Broads, cruising along like something like that. We'll give it a good tributary or two coming out of these high mountains. And then we'll have a river here that comes down off of the Blue Ridge and flows out to the Atlantic. Okay. So if we zoom in on this landscape, the French Broad going to be looking something like this, where it develops that that sort of gorge almost that it's cut down into. And it does that right where it kind of flows out of the Blue Ridge, where it's flowing off of these gray Blue Ridge rocks here, and entering those purple rocks of the Appalachian Valley and Ridge. Two really different rock types. The Blue Ridge stuff's harder to erode, and the river has to kind of step down off that to get into the Valley and Ridge. For that reason, around Hot Springs or something like that, the river is very much cut down into the landscape. How far does that cutting into the landscape spread upstream? Well, it's a little bit above Asheville at this point. And if we threw some labels on here, we would have Asheville there, Marshall would be something like there. Hot Springs would be something like there. Uh, Knoxville, I don't know, a place out in the Valley and Ridge would be something like that. Upstream, you say like a Hendersonville or a Mills River would be something like that. So all the Western North Carolina places they're in the Blue Ridge. They're in a geologically different part of the Appalachians from what's in the Valley and Ridge, and to some extent from what's in the Piedmont as well. And for that reason, the river networks there are, they're very much a product of what you're going to get geologically in that part of the world. Now, if you put some really extreme rainfall up here right on the edge of the escarpment, some of that's going to run out into the Atlantic rivers, like the Rocky Broad that destroyed Chimney Rock, and of course, a great deal of that is going to flow into the French Broad as well. So having all that rainfall sitting right in the headwaters of the French Broad and the rivers that go out to the Atlantic as well, that's your recipe for a flood of this magnitude. And once that flood is in the river channel, it's going to get to places like Marshall and Hot Springs, even if there's not a lot of rainfall there, right? So when you're looking at that landscape, you have to sort of think about what's underneath it, and how what's underneath it makes the mountains look like they do and sets them up to capture so much rainfall, right? So we'll hop back to the maps now. Okay, so hopefully that gives you a sense of why the river is laid out like it is, and how a river like the French Broad could actually end up getting steeper as it gets bigger and produce that sort of confined river valley. Now, the French Broad, because of its size, it's sort of the granddaddy of southern Appalachian rivers down here. Its drainage area is absolutely huge. It is responding, to the overall structure of the Appalachians. Now, that being said, you can see similar patterns in its bigger tributaries, particularly when they reach the French Broad around Asheville. The Swannanoa River is a very good example there. It has very high elevation headwaters. We'll look at this here in just a minute or two. Up here above North Fork, 6,000 feet, about 4,300 feet here in the Swannanoa Mountains. That can wring a lot of rain out of weather systems if they come out of the south. And all of that precipitation runs off down here into the Swannanoa River. Now, where is Swannanoa itself? We'll mark a little indicator of where the town is on this map. It is in an area that has a degree of topographic confinement, but there's some potential for the river to spread as it rises in this area. The flooding here was absolutely at considerable velocity, even when the river was out of its bank, just the fact that structures were carried so far by it. But as you move downstream of Swannanoa itself, you do start to get into an area where there's a little bit more potential for the river to spread out. And that's particularly in this area right here. We fade the overlays. You can actually see those agricultural fields there, and the river channel itself lined with trees. Now, just downstream of this area, there's a big change in the Swannanoa. It enters sort of a confined channel, kind of like almost like a miniature gorge, if you want to call it that. And a friend asked me about this specifically, in particular about a place here called Driftwood Court that's right along the river. Very devastating flooding here, bad outcomes associated with that. And this is a place where again, simply the landscape and the shape of the river and the changes it has experienced moving downstream absolutely sort of amplified what was going on with the flood event here, because this big wide area kind of necks down, into this tight channel. We can turn off the topography overlays here and actually look at what happened here from a satellite perspective. And this is an area that was devastated and sort of changed, if you want to use that word, much in the way that the Cane and the Tow rivers were. So you're now looking at pre-flood satellite imagery. That's post-flood satellite imagery. Incredible scouring of the channel. The river is literally wider now than it was before. And just the amount of tree and soil loss along the banks that would be necessary to produce this is quite considerable. If you look upstream of that gorge, above that gorge, which in this case is to the east, there's still trees lining the river where the river was able to spread more. The driftwood court area is right here where the hand is located, and in this particular case, the grain of the land is different, right? So a flood event moving through is going to interact with the land differently and impact the land and whatever is built on top of it very differently as well. And this again, it's sort of like a smaller version, really, of what you could visualize with the French Broad itself as it makes its way downstream from its upper valleys, around Hendersonville or Mills River, which are somewhat flatter and more gentle, into that very confined stretch that begins around Asheville and just gets more confined going downstream. See if we can get that black line off of there. Okay. So as a final thought here on the Swannanoa, we'll look out over this little gorge here and look upstream. Again, seeing the land like this, I mean, it has value in terms of just understanding where you are and where the water is going to come from in an event like this. Hopefully those overlays have caught up there. Okay, so we can see the gorge there in the foreground. And if you actually think about where water came from to this gorge or to Swannanoa above it, got it coming off the Swannanoa Mountains here. We'll start there and just start illustrating the course there. So we'll go up above North Fork up here. I mean, this is 6,000-foot topography there. So huge high mountains. And all of these little streams here are just pouring more and more water down into the Swannanoa. We'll go up above a bee tree here as well. So when you start to see the land like this, see if we can go up behind Montreat as well, give you sort of a full view there. The mountains are just concentrating that water down into that valley, and when it gets to a place, particularly like this down here, where it becomes confined in that gorge, it's going to be massively destructive. And really thinking about rivers like this throughout the Blue Ridge is important to do, because river characteristics in this part of the Appalachians tend to change quite a bit. And the pattern that I've been talking about here, where you have really high headwaters, then things flatten out, and then you start to carve more of a gorge again by the time the river's quite a bit larger, that's a pretty common pattern. And how that pattern is going to impact floodwaters is something that's actually quite significant in terms of how the landscape is going to behave during an event like this. So hopefully that puts a little bit more of the French Broad into context. I'd like to zoom out one last time here so we can look at it in its entirety. I need to do, sort of a full scale rivers overview. I've got the French Broad here right in the center. So again, it's just an absolutely vast river system. And by the time it even gets to Asheville, which has the hand sitting on top of it right there, it's big, to say the least. Got the Tow and the Cane up here flowing to the Nolichucky. Got the Watauga River up here, the Doe, the Elk. In this view, you can actually see up here into the New River headwaters that go up into Virginia and West Virginia, where there was considerable flooding, absolutely, from this event. So thinking about these rivers that are north of Asheville, you've got the Pigeon down here, south of Asheville, that I-40 follows into Tennessee. All of these river systems had big impacts, and it's also valuable just to see where they all go and to see where they all start, because how that layout interacted with the weather is another big part of understanding what went on here. So I hope you found this video useful. I'm going to try to do a couple more here. I want to get a video out in the field as well because I've been looking at some of the debris flows in Western North Carolina. Not sure which one will come up next, but hope you check it out when it does.